Good morning, and once again, welcome to my YouTube channel, Pearson and Excel International Maths by Mr. Kamotho. And today we will be looking at example 8 of chapter 5, exponentials and logarithms. It's a question that is quite long, and I want us to first of all understand it before we work it out. And we are being told that the graph represents the growth of a population of bacteria P over T hours. The graph has a gradient of 0.6. It is important to note that and meets the vertical axis at 0,2 as shown. A scientist suggests that this growth can be modeled by the equation P is equals to AB raised to power T, and please note only B is raised to power T, where A and B are constants to be found. Part A, write down an equation for the line. And part B, using your answer to part A or otherwise, find the values of A and B, giving them to three significant figures where necessary. And part C, interpret the meaning of the constant A in this model. Having understood the question, it is important to put down what we have. We have a graph that looks like this. Let's have the graph. The graph itself looks like this, and this is 2, and this is the logarithm of P, and this is what we're calling T. This is time T. Of course, this is 0, and that's it. So we have a relationship, or we have a scientist suggest that this growth can be modeled by the equation P is equals to AB raised to power T. And remember, we talked about the gradient. The gradient we are given here, the gradient 0.6. This is very important. This one should not escape your mind. Where A and B are constants to be found. The first thing, or the first part of the question, or rather part A, is write down an equation for this line. And we all know that this is an exponential relationship, and the very important thing for everybody to remember, in an exponential relationship, we should always introduce logarithm to base 10. And what do we have? Introducing logarithm, we have logarithm of P is equals to, is supposed to be, the logarithm is supposed to be equals to logarithm of AB raised to power T. And remember, all these logs are to base 10. And of course, using the multiplication law of logarithm, whereby we all know that when the logarithm of P is equals to the logarithm of A, of course, plus the logarithm of B raised to power T. And this again is going to undergo some other processes, because this being an index should become a coefficient of the same, and therefore the logarithm of P is equals to T logarithm of B plus the logarithm of A. And this one is already now in the form of y is equals to mx plus c. And I want us to look at the whole arrangement and compare the two. When we talk about y, comparing with the log of p, which is in the y-axis, and you can see that when you talk about the c compared to the y-intercept, you can see that. And we are already told t was the other variable of time, which compares very well with the other variable of x. So ideally, the logarithm of b should actually be our gradient. And this gradient is already given here. So in an attempt now to look for the equation, which is just direct, the equation which is very direct, we should be able to know, or to give the equation in terms of the logarithm of p is the gradient, which is 0.6 t, of course, plus the 2, because we are talking about the y-intercept. Then at that point, we have given the equation, or rather the relationship of p and t as far as this graph is concerned. You can see along the y-axis we have log p. We can see along the x-axis we have t. We have log p along the y-axis, which is represented by y. We have the gradient 0.6, which is represented by the log of b. We have t on the x-axis, which is normally x. And we have log of a as the y-intercept, which is always the c. And in this particular arrangement, our c is 2. So yes, that is the equation of of the line. Part B, we should be able to look for the values of A and B. And now that we have this equation and we have this arrangement that log P is equals to T log B plus log A, what we are saying is that the log of B, which is the logarithm into base 10 of B, is simply 0.6, because that is ideally the gradient. And what this means, we just talk about the anticlockwise movement, and it tells us 10 raised to power 0.6 should give us the value of B. And if you pick our calculator, what we have here, 10 raised to power 0.6, giving us 3.98. And that is just our value of B. So our B is 3.98. That is our value of B. What about A? You can see very well that our C in the graph, which is 2, is ideally given by the logarithm into base 10 of A. So it is, we have all reasons to write the logarithm into base 10 of A is equals to our C, whereby our C is 2 in this case, is equals to 2. So it follows that again, if we employ the anticlockwise movement, because this one is in the logarithmic notation, if we wish now to write it in the index notation, then we employ the anticlockwise movement, which is 10 squared should give us A. And ideally, our A is 100. And that is just like it. Our value of A is there, our value of B is there. So part C is asking us the value of A given, interpret the meaning of the constant A in this model. The meaning of the constant A in the model is just very simple, because what do we have to say? Of course, A is brought about in the real life by this graph, which is represented by 2, because you can see the logarithm into base 10 of A is 2 in our graph, as far as our graph is concerned. And now that ideally we should be talking about A in the real life, therefore A being 100 is actually the ideal y-intercept. Is the ideal or it is the real life? Is the ideal or is it the real life y? It is the real life y-intercept. It is the real life y-intercept. And of course, when we talk about y-intercept, whereby we are having 100, it means then this was the initial population. This was the initial population of the bacteria. What does this mean? At time 0, that is, at t is equals to 0, there were 100 bacteria. That is just what it means. And we have interpreted the meaning of the constant C ideally. So it's important that we follow and be able to interpret. That is it, the end of example 8. Please subscribe to my YouTube channel Pearson Edexcel International Maths by Mr. Kamotho, whereby we explain each and every example and give more details as far as this specification is concerned. Please remember, we've always explained pure mathematics 1 to 4, IG's International GCSE, statistics, and also mechanics. So please follow and subscribe and share widely. Thank you.